Alright, let's take a look at questions 21 through 28. Number 21 is the limit as x goes to infinity. They want to know what it is, and so we look at it and determine if the exponents are bigger on bottom, bigger on top, or if they're equal to each other, and then just apply our little trick here, Bobo Batu Betsy. Another way of them asking this could be, what are the horizontal asymptotes of this? So if that's the case, then you can apply the limit as x approaches infinity to give you that horizontal asymptote. Okay, and on 22, the graph is 1 minus x over x squared minus 1. Okay, and this is the function, f of x. Well, notice that we have a square on the bottom, minus a square, so we have x plus 1 and x minus 1. And it looks like if we were to factor a negative out of this numerator, we would have what? Positive x minus 1. So factor the negative out. So we have a negative 1 over x plus 1. Okay. And before we move any further on this, notice that we're going to have an asymptote at what? Negative 1. And the function itself is going to have a hole at x equals 1. Even though we've removed that, removable discontinuity is going to create a hole somewhere in this graph. So this is pretty helpful. So we know that at x equals 1 and x equals negative 1, the function is not defined there, right? So let's go ahead and keep moving on with this. If we wanted to, we could just graph this one, and we could see what happens. We know this thing's going to approach this, and it's probably going to be, not probably, but it's going to be upside down here, and something over here. We could plug in a few values and see if it's concave up or concave down, but if you don't see that, it's not a big deal. We can go ahead and take the derivative, but we'll take the derivative of this, and then we'll take the second derivative and see where it's concave down. So the first derivative of this would be what? Well, another way of writing this function, I guess we should say, is negative 1 times x plus 1 to the negative 1 power. Right, this whole thing is to the positive first power. So if we put it up on top, it's to the negative 1 power. So the first derivative would be positive 1 times x plus 1 to the negative 2. And then the second derivative would equal negative 2 x plus 1 to the negative 3 power. And I guess we could rewrite it like this. And oops, that would be a positive 3 since we moved to the bottom. And the only point of inflection, possible point of inflection, would be at x equals negative 1. But keep this in mind right here. At x equals 1, the function itself is not defined. So I'm going to go ahead and take a look at positive 1 and negative 1. And this one could be a possible point of inflection. And I want to do it over here because the function itself does not exist. So what happens here? So we're going to look at 3 intervals here. So we're going to come right here, pick a big negative number. You cube a big negative number, and it's still negative. Negative divided by negative is what? Positive. So it's looks like it's concave up in that region. And what about between negative 1 and 1? Pick 0. So at 0, the bottom is positive 1 cubed, and you have negative 2 divided by positive 1 to give you a negative. So it's concave down between negative 1 and 1. And remember, at 1 it doesn't exist, so let's go ahead and check it out over here at big positive number. So you take a big positive number, add 1 to it, and cube it, still positive. But you divide -2 by that big positive, and you get another negative. So it's concave down here, but remember that since it doesn't exist there, there's really, technically, it's not really concave down in that region. So keep that in mind when you're answering that one. Okay, let's take a look at 23. 23 has a picture of a graph, and it's sort of overlapping. One starts off here, and the other one kind of does this, and they come together at, looks like 1, 1. And you have x squared here, and the square root of x there. And they want to know not actually what the area is, but what's the integral of that. So just set up your limits of integration. Most of this can be done straight from the picture. Top curve minus bottom curve. And we're going to go from, looks like, from 0 to 1. And with respect to x, of course. So I'll let you hammer through that one. And let's look at 24. And 24, the first thing we're going to look at is, what are they asking us for here? Well, they have this set up, tangent of 2 pi over 8 plus h minus tangent of pi over 4 and over h, and limit as h goes to 0. So we're thinking right away that we're going to have to calculate the derivative. Well, we're going to take the derivative of what? What's this overlying function? It's tangent, right? So basically the question is, what is the derivative of 2x? Alright? Well, normally these two numbers right here will match up. What's 2 times pi over 8? 2 times pi over 8 would reduce to what? Pi over 4. So they, in fact, do match because of that 2 right out in front of here. So what is the derivative of tangent of 2x? Well, the derivative of tangent is secant squared 2x, but then you have to multiply it by the angle, or the inside part, which is just 2, not 2x, times 2. And remember, this is the angle, right? So, and where are we going to evaluate it at? At pi over 4. So, excuse me, at pi over 8. So we have the secant squared, which is 1 over cosine squared of 2 pi over 8, and then we're going to multiply that by 2. So we're really looking at 2 over the cosine of pi over 4, and that answer is squared. So pi over 4 positive, so square root of 2 over 2. And then we're going to square that. And we're going to get what? Square root goes away, and that turns into a 4. Of course, if you see the shortcut, that cancels with that, and the 4 will go on top. The answer is going to be 4, but if you don't see that right away, just change the division to multiplication and reciprocate the denominator here. And then you'll see quite simply that those cancel and you get 4. Alright. Looked tricky at first, but it's really pretty easy. Okay. On 25, I'll give you a little hint on this one. 25 is a definite integral from 1 to e squared of ln squared of x over x dx. So anytime you have a complicated integral, think about the u substitution. And what's the scariest looking part of this? That's usually a good place to start. And ln of x looks pretty scary to begin with. So if I make the u ln of x, the derivative is equal to what? This 1 over x. So try to keep this confined over here to the right side. We have that du times x is equal to dx. Alright? So, and what if I wanted to change my limits of integration? If u is equal to ln of x, let's try this. So to find the lower limit, what is the ln of 1? And what is u when we're doing the ln of the upper limit, e squared? Well, this one is what? If you forget this, always keep that picture of the graph in your mind. E to the x is this, ln of x is that. And it always crosses this at 1, 0. E crosses at 0, 1, and since they're inverse functions of each other, this answer is what? 0. And ln and e cancel each other out. So what do we get? Well, you could use the power rule over here to simplify this. U is equal to 2 ln of e, and since ln of e cancel, the upper limit would be 2. So let's rewrite this. We have 2 to 0, and now let's take care of this. Ln of x is equal to what? U, and we got to square it over x, and dx is equal to du times x. So du times x, and the x cancels. So you have just simply integral from 0 to 2 of u squared du. Okay, I'll let you finish up from there, but now since we have these are in terms of u, we don't have to go back and resubstitute in. Alright, let's take a look at 26. Okay, this one, they give us the position function, right? And they're asking us to find what? The average velocity. The average velocity. Since this function is over time, if you graph the position, this is t, and this is, say, meters, for instance. If you got some function here, and you want to know the average between 2 points, the average velocity is the slope of the secant line, right? So we don't have to take the derivative or anything. We just have to just find the slope of the secant line between 0 and 2 pi. So the function is sine of t plus 2 cosine t plus t over pi plus 2. And we're looking at it between 0 and 2 pi. That's the interval we're trying to evaluate. So we're just simply going to do this function value, which is actually s at 2 pi minus position at 0 seconds or whatever, and 2 pi minus 0. So this is just the rise over the run, or the slope. AROC, average rate of change. So, average rate of change, I always think algebra, think slope. Good luck. Alright, flip to 27. 27. Looks like a piecewise function. And the question is asking us, you have e to the x, I suppose. And the bottom function is just 2 when x is greater than or equal to natural log of 2. And here, it's when x is less than the natural log of 2. And the question is asking us, what is the limit as x approaches the ln of 2? So, it's not from the left, it's not from the right, so we have to evaluate both of them and see if the limit exists, if it is a value. So, well, let's see. Let's do the top one. I'll do that in red. So it's e to the ln of 2. And the bottom one is simply what? 2. So do the green and the red match up? If they do, then you just found your limit. So, use your properties of E and ln and you should see that they do equal. So, kind of gave that one away. Alright, and number 28. Let's see, turn the page. Oh. Okay. Alright, 28's a little involved problem here, so I'll have to get it set up. Maybe we can talk about it in class. We got this labeled as 10. This is the height, and this is the angle theta down here. And the question's saying, if theta is increasing at a rate of 15 over 26 radians, so d theta dt is equal to 15 over 26 radians per minute. Alright, and they want to know what is the rate, what rate is the area of the triangle increasing in square units per minute when the height is 24. So they're asking us dA dt at a height of 24. Okay, well, height. So what's the area formula, by the way? That's really what we need to look at. Area is 1/2 of base times height. And the base isn't changing. The base is always 10, so this is 1/2 of 10 times height. So really we're looking at the area is equal to 5h. Alright. Well, how do we figure out and remember we have, this is d theta dt. In this area formula right here, there is nothing that's going to give us anything to do with an angle, right? This is all right triangle trigonometry. So how can we express the height in terms of theta? Well, theta, h is opposite, and 10 is adjacent, so SOHCAHTOA tangent of theta is equal to h over 10. So let's take a look at taking the derivative of this. We got secant squared theta d theta dt is equal to what? 1/10? Well, maybe we didn't need to take the derivative of this. Let's just rearrange that. Let's see what h is equal to in terms of theta. So if we cross multiply, h is equal to 10 tangent of theta. Okay, well this is more what we're looking at here. So now we can substitute this h for this h here and get that the area is equal to 5 times 10 tangent of theta. Alright, so now we have 50 tangent of theta, and now we can take the area. The derivative of the area would be dA dt is equal to 50 secant squared theta d theta dt. Alright, well let's see what we know. We know 50 is constant, and we know what d theta dt is. It's given to us up here. All we need to know is, well, what's this angle theta? Well, when h equals 24, and we need to know that, and secant is what? Cotangent, secant, cosecant. So looking at our rainbow here, secant is paired up with cosine, right? So I need to know the cosine of this guy here. We could use Pythagoras theory. At h equals 24, we would have 10 squared plus 24 squared is equal to the hypotenuse squared. Alright, it turns out that's 26. Let's see. Well, let me give you just a little shortcut here on this one. Since this is a non-calculator, these are even numbers. So if I take half of 10, I get what? A triangle that looks like 5 and 12. And now this would be 12 squared, 144 plus 5 squared, 25. So you have the square root of 169, which is equal to 13. And then you double it to get 26. So anyway, what is the secant of theta? We have 50 over 1 over cosine of what? What's cosine of this angle? Cosine is the adjacent 10 over 26. So we have 1 over 10 over 26 squared times, what's d theta? 15 over 26. Alright. Well, doing some arithmetic on this, we could simplify this, and we could do 26 over 10 squared, that's squared. Alright, just trying to make our life simpler here. 26 cancels out with one of those. That's equal to 100. 150. That goes 1, that goes to 2. So on top we have 26 times 15 and 2 on the bottom, right? 2 and 26, that'll take this down to 13 and take this down to 1. So we have 1 times 13 times 15. And let's see. That's 65 and 3, 1, 5, 9, 1. 195. So looks like 195 is one of our answers. So let's see. So that takes care of that part of the test. Hopefully I'll get more up soon on this. Okay.